Hey guys, welcome to Tips and Tricks. This is Viren here. Some of you may have come here, after looking at my video number 5 in It's All About Networking, and some of you may have landed here, just searching for binary to hexadecimal or decimal kind of conversions. All right, so let me just quickly, take you through all these. So as you can see, binary just has two numbers, 0 and 1. We have a base 2. Decimal has 10 numbers, and that is why it has a base of 10, and hexadecimal has a base of 16 because it has 16 numbers. So the conversion from 0 to 9 from decimal to hexadecimal is not needed till 9, but after that 10 is called as A, 11 is B, 13 is C, D is 13, E is 14, and F is 15. So let me just open my scratchpad and quickly run you through all these conversions. So first of all, binary to decimal and vice versa. Alright, so the very first one, binary to decimal and vice versa. So as you can see, binary is just made of zeros and ones. So when you're doing binary to decimal, just remember this format, or the increment of 2 raised to the power 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, and we can go after 2 raised to 8 also, but the reason we stop and the 8th bit most of the times is because the IP address is just 8 bits, and if you see here, these are the 8 bits: 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, we stop at 2 raised to 7. So this is where we stop most of the time. So let me just real quick tell you the values I know here. It is 1, 2, 4, 8, 16, 32, 64, 128. And as I said, you can go ahead also, but that's not needed in terms of networking most of the times. So the conversions are really very quick. So let's say 10011. This is your number in binary. You'll start from the left side. So this is checked, so this is 2, I'm sorry, that is a 1 plus 2, or you can start from the other side also, but if it's a perfect 8 numbers, then we can start from the other side, but I'll start from here. Then we don't have anything, then we have 2 zeros, so that is the 4 and 8 zeros, and then the 16 bit is on, so we have 16 plus 2 plus 1, so this is 19. Alright, I'm going to convert 19 of decimal back into the binary. So again, how do I get 19? Look at the top table. So since I've been practicing, I know about it. So what I can do is I can take this 16 and I can take these 3, right? So this will be 1 0 0 1 1. That's what it is, 16 plus 2 plus 1. So we got 19. So this is 1 0 0 1 1. Alright, let me just go to another example. Let's say this binary of 1 0 0 1 0 1 1. Now again, look at the top table, and you will see that what all is needed. So if you see, these are 4 5 6 7, these are perfect 8 numbers, so I know. So this is 128 bit is on, then you have 0, then you have a 0, then you have a 0, so 64 is gone, 32, 16 is gone, and then the 8 is on, then the 4 is not on, and then we have the 2 and the 1. So the total is 128 plus 8 is 136 plus 3, this is 139. Now I'm gonna convert this 139 of decimal back into binary, how much will that be? So again, you look at the table. So 139, how can I make 139? You look at the table. So I'll have to turn the 128 bit on. Okay, so 128 plus 64 is 192, which is crossing 139. So I'm gonna turn this 64 off, and then do I need 32? 128 plus 32 is how much? 160. Again, that is also crossing, so I'm gonna turn off that bit also. 128 plus 16 is 144, so that is also crossing 139, so that is off as well. So 128 plus 8, that's 136, so I will need this. Okay, so 136, so I need 3 more. So you know that the 3 is the last 2 bits, 2 and 1, and the third bit, which gives the value of 4, that is also not needed. So my value is 1 0 0 1 0 1 1. That's it. So these are your binary to decimal and decimal to binary. Before going, I can give you one more very simple example. What is 192? Because you see 192 a lot in your IP address. 192 in decimal, what is it in binary? Because I know 128 plus 64 is 192. Rest are all zeros. That's your binary. Similarly, 110000 of binary into decimal. I know these are all zeros. I know this is 8 numbers, so this is 128, this is 64. The answer is 192. Okay, let's move on to the next one. Binary to hexadecimal and vice versa. Now in binary to hexa, we start working it in nibbles. And you know what a nibble is. A nibble is basically a combination of 4 digits, 4 bits. So we know that 1011, this is a nibble, and when I say 1001 1011, that is now 8 digits, so that is a byte. So when we start talking about binary to hexa, I'm gonna give it a short form, we start talking in nibbles. So let's say 1011, what is the value in, what this is in binary, so what is the value in hexa? So again, you know that, again start looking at what is this? This is 1, this is 2, so this makes it 3. 0, there's a 4 here, 1 2 4 8. So as you can see, the bit representing 4 is not there, is turned off. So the value is 8 plus 2 plus 1, so which is 11. But we don't write 11 in hexa, so this value is actually B. Okay, let's go to a bigger example. So let's say I'm gonna take this example here. So 1001 1011 is what in hexa? Remember, now breaking the entire thing into nibbles. So 1 2 3 4 from the left side, so I'm gonna break it. So now we have 2 nibbles. So value of this nibble is we just saw that this was 11. What's this? This is 9. We again start counting from here. 1 2 4 8 1 2 4 8. So the value of this is 11, which is B, and the value of this is 9. So the value of this number in hexa is 9B. Alright, so now I'm going to convert 9B of hexa back into binary. So I know that B is actually 11. And how do I write 11 in binary? 1011, that's a value. How do I write 9? 1001. There's your value of binary. I hope this is not confusing. If do you want me to give more examples? Let's say I'll give you one more example. So let's say 111 1001. Now here this is your binary and this is your hexa. So again, when I'm dividing it, you'll see that there are 3 bits on this side and 4 bits on this side. I mean, we've got a nibble here, but not a complete nibble on the other side. But that doesn't matter. So the value on this side is 9, and the value on this side is 1, 2, 4. That's 7, because there's nothing on the fourth one. So the value is 79. Similarly, if I want to convert this 79 of hexa back into binary, so I know that 9 in binary is 1001, because this is 8 and this is 1. 4 and 2 are not needed. And then I can write 7 as this. I can add a 0 here, and that's fine. This is your value. So binary to hexa, hexa to binary. Remember, always deal in nibbles. Now we move on to the last one, which is, let me just clean up the board, which is hexadecimal to decimal to hexadecimal, and vice versa. Alright, so we have the last part. So in that, what I'm gonna do is I'm gonna first cover hexa to decimal. So now always remember, when you're doing a hexa to decimal, just follow this path. Make a hexa as binary and then make it decimal. Makes things easier. So let me give you an example. So let's say 71 of hexa is equal to what in binary? So how do we write a 1 in binary? 0, 0, 1. And how do we write 7? We just saw that. So that's your number. Now this binary can be converted into decimal. We already saw that. So what is this number? So I know this is 8 numbers. So we have 128 bit is off. So 64 plus 32 is 96. 96 plus 16 is 110. So basically this is 111 in decimal. Okay, I'm gonna check that once again. So 128 is off, so I'm gonna 64 plus 32 plus 16. What this is 96 plus 602, 112. Yeah, I knew that something is wrong. So this is 113. Okay. Now let me convert. Alright, let's check one more example of converting a hexa into a decimal. Let's take any example. Let's take a weird example of hexa. A7, that's how they write, right? We have A's and all that in. So A7 in hexa is what in binary? So 7, as we we can write as, this is 7 and a 0. So this is 4 plus 2 plus 1, 7. How do we write A? A is basically a 10. And how do we write a 10? We just write 8 plus 2. So how do we write here? 8 plus 2. So this is 8. You see, these are the two nibbles. 8 plus 4 is turned off, and the 2 is turned on. So we have 1 0 1 0. Now, so we have the binary. Once we have the binary, we can convert it into decimal now. So now again, these are 8 numbers. So I know what's happening is 128 plus 64 is turned off, plus 32, 16 is also turned off. So this is the value we have on this nibble, and the other side we already know it's 7. So what do we have? This is 160. So this value is 167 of decimal. Alright, so this is the path you should take when you're converting from hexadecimal to decimal. You should always go through binary. It makes life simple. So what I'm gonna do is now, there is another way though, but we will not look at that. Now we will convert the decimal into hexadecimal. Okay, so when you're converting from decimal to hexa, that's where the division comes, and this is the only place where you will see division. So now you see that we already converted the hexa A7 to decimal 167. I'm going to take that example. So 167, what I need to do is I need to divide by 16. So let's say 16 into 1 is 16, and we've got a 7 as a remainder. So I'm sorry, 16 into 10, we get 160, and we get a 7 as the remainder. So whatever remainder you get, you write the remainder here, and you again start dividing whatever is left here. So 10 divided by 16, but it's not possible. So whenever it stops here or it's not possible, then you write this value as it is here, 10, which is equivalent to what? A. So this is A7, and then you write it upwards, A7. So that's the value. So let me take another example. So let's take some weird examples. So let's say we'll convert 213 of decimal into a hexa. So what I'll do is I'll divide this 213 by 16. So I'm gonna say 16 into 1 is 16. So if we get a remainder of 5, 3 comes here. 16 3s are 48, and we've got a remainder 5. Now I still cannot further divide this 13 by 16 because it's not possible. So first of all, I'll write the remainder here 5 and 13 as it is. And what is 13? That's nothing but D in hexa. So we go upwards, so the answer is D5. That's D5, that's your value in hexa. Alright, now let me just convert that D5 of hexa back into decimal just to make sure that we are correct. Okay, so hexa to decimal, and I just taught you when we go from hexa to deci, we get one binary in between. So what is the value of D5 in binary? We know how to write a 5 with just 4 nibbles. I know that this is 1, this is 5 because this is 4 and this is 1, this is a 5. And how do we write 13? So 8 plus 4, 12 plus 1, 13. You see both the nibbles? This value is 13 and this value is 5. So D was 13. So that's how. So we've got our entire binary. So our entire binary is 1101 0101, and now we convert this into decimal. So we know these are 8 numbers. So 128 plus 64, that's 192. 192 plus 32 is 32 bit is off. So 192 plus 16 plus 4 plus 1. So I've just not considered the bits that are turned off. So 192 plus 16 is 198, that's 208 plus 4 plus 1, 213, and I guess that was our number earlier. So this is 213 of decimal. Okay, now let's take one last big example so that you can have an understanding. So I'm going to take 1056 of decimal into hexa. So again, decimal into hexa, division. So I'm going to take this 1056 and start dividing it by 16. So I know 16 times 6 is 96. I get a remainder of 99, and then 6 comes down, and then I again do a 6 into 6, 96, so I get a 0. So I'm gonna, now don't get confused that this is completely divisible so it's all over. No, if you see here, the 66 is still divisible by 16, so we will not stop. sorry, we will not stop. So I will take the 0 here, and now I'll start dividing the 66 by 16. I'm sorry. So I get a 16 for the 64. I get a 2 remainder. Again, I'll put the remainder here. And that 4 is not divisible by 16, so I'm going to put the 4 as it is. I'm going to go upwards. So 1056 in decimal is 420 in hexa. Now how do I confirm that? Let me just confirm. Let me just convert 420 of hexa into what is the decimal value. So 420, how do we convert that? So just like we have the increments of 2 in hexa, we have increments of 16. So 16 raised to 0, 16 raised to 1, 16 raised to 2, and so on. So the 420 that we see here in hexa, what we need to do is the 0 will get multiplied with 16 into 0, 2 will get multiplied with 16 is to 1, and 4 will get multiplied by 16 is to 2. So we will have something like this. 4, let me just clear that off. So wait a minute. So we will have something like this. We'll start from the left side. So we had the number 420 in hexa. So 0 into 16 raised to 0. This will be added by 2 into 16 is to 1, and 4 into 16 is to 16 raised to the power 2. So this is 0 into 1, which is 0. This is 32, and this is 16. 16 is 256. 256 into 4. How much is that? So that's 4 6 are 24, 2, 1024. 1024 plus 32 plus 0. This comes 1056 into decimal, and that's what our number was. So I guess that the picture is quite clear for all the conversions. If you still have any issues, do feel free to put in your comments. And as you know that some people have come here by looking at my video number 5 in my channel. It's all about networking. So if anybody is interested, please feel free to subscribe to that channel, and it'll help you in your CCNA. So thank you for watching this video. Have a great day.